get started. Okay, well, my name's Daniel Bobias. I'm an infrastructure architect at Datacom. And first thing I want to do is actually thank you all for coming. There are heaps of sessions on. I was sitting in Tony Murray's session yesterday, and he said, you know, you turn up to 16 out of the 168 sessions, so I appreciate you turning up to mine. So I'm going to take you through a couple of new networking features in Server 2012. And obviously, like I mentioned, we're going to be giving away a laptop at the end of this. But look, if there's one thing that I'd like you to take away from this session, it's this. Server 2012 simplifies your infrastructure. So, what are we going to talk about? So I'm going to take you through network interface teaming. We're going to have a look at DHCP failover in Server 2012. And we're going to have a look at a brand new feature called IP address management, IPAM. So, network interface teaming. Now, Microsoft also call this load balancing and failover. After morning tea, so people should be over their hangovers by now, we can get some hands up. How many people have implemented network teaming on one of their servers before? Excellent. Thought that might be the case. So this is the interesting one. How many people have had trouble with network interface teaming on their servers before? Yeah, about the same amount of hands. It's been interesting. So just for those people which haven't done teaming before, and so we all get on the same page, a team is essentially a bunch of physical interfaces grouped together to act like one interface. So down the bottom here, we've got our physical interfaces. They get created into a team. And at the top, we've got our logical interfaces. Now, the reason we've got more than one logical interface is if we're doing VLANs, and we're doing VLAN tagging within our team. So what are the reasons that we want a team? Okay, so the first reason is resiliency. We want to protect against a layer 2 failure. We want to protect against a patching problem, a server NIC going down, or a switch going down. The next reason is bandwidth. Okay? We want to get more bandwidth to our application than one interface alone is going to allow to happen. And I actually think there's a third reason as well, and that's VLANing. So we want to get more than one VLAN, sometimes on the same interface, up to our server, and we can do that with NIC teaming. So, Server 2012. Well, the first thing, NIC teaming is now built into the OS, so we don't need to install third-party teaming software on the server. And the other really big thing, it's now supported in Hyper-V. So with 2008 R2, NIC teaming wasn't supported. You had a PSS call that would tell you to turn it off. 2012, it's fully supported. The UI has been built into the new server manager. You've probably all seen that before. If not, we're going to have a look in the demo shortly. And there's full PowerShell commandlet support for NIC teaming. Now, the other really interesting thing, we can now do NIC teaming inside our VM guests. And I've got a couple of slides on this at the end of this set of the presentation. And there are a couple of rules around that and reasons why that happens. One of the big things for me, though, because NIC teaming is now built into the OS, it means we get true vendor-agnostic teams. We can have multiple vendors' adapters in the same team. I know some vendors allowed you to do that previously, but you had to have like one of their NICs. That doesn't matter any longer. One of the key things, though, you can only team interfaces which are the same physical connection. And by that I mean you can't team a wireless LAN interface and an Ethernet interface together. They all have to be Ethernet. Can be different speeds, though, if you want. So before we have a look at the UI and a bit of a demo, there's two really important things we need to understand with our teams. We've got this thing called our teaming mode. This is essentially how our team interacts with our network switching infrastructure. And it's kind of important we get that right, because if we get it wrong, the switches get really confused, and essentially bad stuff happens to our packets. So we have two teaming modes. The first teaming mode is called switch-independent mode. Now in switch-independent mode, each of our physical interfaces connects to a different switch. And there's no configuration on the switch. So each switch thinks it's the only switch carrying that traffic. Our next mode's switch-dependent mode. Now in switch-dependent mode, each of our interfaces usually, and I'll cover off why in a second, connect to the same switch. We have to put some configuration on the switch. We have to configure an LSAP trunk, or we have to configure a static team, okay? And that basically tells the switch to treat those interfaces as one logical interface, and that it can put traffic across all of them. Now, I said there's a variation to this, and this is if your switch supports switch stacking. Now, with a switch stack, you connect your switches together using some special stack cables, and they behave as one logical switch. And in this configuration, you can have an LSAP team across multiple switches. But you can see here, if your reason for teaming is resiliency and your switches don't support switch stacking, then having switch-dependent mode and all your interfaces connected to one switch may not fulfill the requirement that you had for teaming in the first place. So the second thing we need to look at is our traffic distribution mode, or our load balancing. And this is how the network team distributes the traffic across the different members in the team. Again, we've got two modes here. Our first mode is called address hash. Okay. So with address hash, we essentially look at the source IP, source port, destination IP, and the destination port, and we turn this traffic into flows. And each flow is put onto a different physical adapter in our team. So we use these flows to spread our traffic across our different team members. The second mode is Hyper-V port. Now, obviously, you only get this if you're running a Hyper-V server. And what happens here is the team distributes traffic across the physical team members based on the Hyper-V port that the traffic's coming from or going to. The more interesting thing for me is when we put these distribution modes and our teaming modes together. So if we have a look at switch independent and address hash, so in this mode, we send using all of our team members, but we can only receive data on one of our team members. Now, the reason for this is our switches don't know that we've got multiple connections, so they can't spread the load across the multiple interfaces for us. So this is pretty good if you've got a workload like IIS, where you've got a lot of outbound traffic, but not so much inbound traffic. What about Hyper-V port and switch independent? So each Hyper-V port sends and receives on one team member. So if we've got multiple virtual machines, because essentially a Hyper-V port's a virtual machine, it's going to balance that load across multiple members in our NIC team. But the important thing here is each virtual machine, each Hyper-V port, can only get the maximum amount of bandwidth that's available on one interface in that team. So you're not going to get more bandwidth than's available on one interface. So again, if your requirement for teaming was bandwidth, this may not fit that requirement. What about switch independent and address hash? We can send and receive on all team members with this mode. So this gives us essentially the best amount of bandwidth possible. Hyper-V port, switch dependent. This is an interesting one. We can send on one team member, but we can receive on all team members. So each virtual machine can only send out to the bandwidth of one team member, but it can receive on all of those. So this is probably good if you're a data sync, you've got lots of incoming packets. But my takeaway here is, just because you're running a Hyper-V server doesn't mean you necessarily need to choose Hyper-V port as your load balancing mode or your traffic distribution mode. If you've got a switch stack, you may choose address hash and switch dependent mode so that you can address that larger bandwidth that you require. So you need to understand what your physical switches are capable of, why you're wanting to team in the first place, and what the traffic is that's going across that team. Right, let's jump into a bit of a demo and have a look at how easy this is. If I push the right button, how about that? Okay, so this is the new server manager. I'm going to presume that people are kind of familiar with it, they've seen it in some other sessions. So if we go to member server 3, and we right-click, and we go configure NIC teaming. So this is going to bring up our teaming interface. So we can see here I've got a team configured already. And let's just double-click and look at this team. So it's got a name, pretty simple. We've got 2 adapters in that team at the moment, ETH2 and ETH3. And down the bottom here, we've got our teaming modes and our load balancing modes. Now, I said there's going to be a couple of slides in a little bit where we talk about what happens with teaming within Hyper-V. The first thing you'll notice, these are grayed out. So this virtual machine knows it's sitting in a Hyper-V host, and it's going to lock me down to only choosing switch independent and address hash as my teaming modes. We're just going to remove an adapter from this team, and we're going to go and put it back with PowerShell in a minute. So the other thing from this screen, you've got your network adapters, and you've got your team interfaces. Now this is where you configure the VLANs that you want to put across your team. So we can go up to our tasks, and we can go add interface, and we can add another VLAN to that team. So now we've got another logical interface that's going to appear within our host for that VLAN tag traffic. But let's go and put that interface back that we moved from our team. So I'm going to do that in PowerShell. I'm going to cheat a little bit. I've got a PSD file with the commands already out, and I'm just going to play them out because you don't need to see me type the command wrong 3 times. So we're going to do a remote PowerShell session to member server 3, and we're going to have a look at the team. Can everybody see that okay from the back? Is it big enough? Yep. So we can see here exactly the same information that we saw within the UI. Our team name, now we've only got one interface in that team, and the different logical NICs. And we can drill in and we can have a look and see, well, let's have a bit more detail about that physical team member. It's ETH2, and we don't have a failure on it at the moment. So let's go ahead and add our interface back again. It's going to pop up, and we're going to choose yes. So we've now added that interface back, and if we have a look at our team, we can see we've got both interfaces back in our team. And if we go back to our UI and go to our network adapters, they're both going to show back up in our team. So it really is very simple to configure. And we're just going to clean up before the next demo. Switch back across. So, I said there were a couple of key things with teaming with Hyper-V. So the first, Stu Fox is going to cover this in a bit more detail this afternoon. So I've kind of pulled this back to sort of just 2 really key rules for the host. So the first rule is, even though you can do VLAN tagging within your NIC team, if you're connecting it to a vSwitch, let the vSwitch deal with that VLAN tagging. So just have a default interface for your team. Don't have a team with lots of VLAN interfaces connected to different vSwitches. That's not supported by Microsoft. They want the vSwitch to do the VLANing for you. Now the next one's pretty obvious, but it probably needs to be said. It's don't team the logical interfaces your vSwitch presents to your host. So if you've created 2 vSwitches and you've ticked the box to say, allow the operating system to see that, don't take those 2 and create a team. Again, that's not supported by Microsoft. So what about within the guest? Well, Microsoft enabled NIC teaming within the guest to support a new type of network adapter. They're called the SRIOV virtual function network adapters. Now, I don't pretend to know a whole lot about them, but they're really cool, and you can do essentially virtualization in hardware. So you have a network adapter, and it can present 200 virtual network adapters up to your host. And that bypasses the vSwitch. Gives you really good, really low latency throughput. But so that guests could still have resiliency, Microsoft have enabled NIC teaming within the guest. Now, there's nothing to stop you from doing NIC teaming on a normal virtual interface, but you've got to remember to set a setting. So you go into the virtual interface and you go to the advanced settings, and you need to tick the box that says allow teaming. Now what that does is it ties the virtual interface to the status of the physical adapter connected to the team. So if the physical adapter on your host goes down, the logical interface on your, in your virtual machine is going to go down. And that's really important, because if that doesn't go down, the team's not going to fail across to the other member. Maximum of 2 adapters. Now this is 2 adapters within a virtual guest. With a host, you get a lot more. And as we saw in the demo, it's switch independent mode and address hash only from within your virtual machine. This is more for if you review the slides later. If you want to get the PowerShell commands, That's the command to run to get all of the load balancing failover power commands. And I'll be putting that up in my blog later as well. So pretty easy to do NIC teaming in Server 2012. You don't need to worry about third-party software, but you do need to understand what's going to happen when you choose some of these settings. All right, DHCP failover. How are we going for time? About right? So, just make sure everybody's awake. Anybody here done 2008 R2 DHCP failover? Now, I'm not talking split scopes. I'm talking proper DHCP failover with 2008 R2. Yep. How did you find it? Good? Took a bit to configure, though? No? Oh, that's good. How many people didn't know you could do DHCP failover in 2008 R2? Yeah, I thought that might be the case. And I'll be honest, I didn't know either until I started doing some research for this. So a recap for everyone else, and I apologize for a minute, sir. You know this already. You need 2 DHCP servers, obviously. But with 2008 R2, you had to install your cluster manager and your clustering feature on those servers. And then you had to put shared storage to be able to configure your cluster. Only once you'd done that could you configure your DHCP for resiliency. Now, in Server 2012, Microsoft have completely redesigned the way DHCP failover works, pretty much from the ground up. Gone's the shared storage, gone's the cluster manager. Actually, everything you need to do failover is now included in the DHCP feature. So, what are some of the things that we need to know? Well, the first one is it's for IPv4 scopes only. You can't do DHCP failover with IPv6 scopes. Microsoft's got a good story around that and some good reasons. I need to cut this presentation by a few minutes so we can give away a laptop. Come and see me afterwards, and I'll tell you why. Next thing you need to know is it's based on an IETF draft standard. So Microsoft haven't gone out and just sort of imagined how it might work. They've actually based this on a proper standard. And it's, for those people interested, it's IETF DHCP failover draft 12 is the standard that they've based it on. They've done pretty well. They do deviate in 2 places, and I'll put that on my blog later on as to where those deviations are. So you get 2 options. You get to choose load balanced, or you get to choose hot standby. And you only get 2 servers in the failover relationship. So no more than that. But again, a little bit like teaming, before we go and have a look at the UI, because the UI is actually really simple, there's some really key things we need to understand about how DHCP failover works in Server 2012. And the first thing that you need to know is Server 2012 DHCP servers are lazy. They use this thing called lazy writes. Now, what does this mean? So with lazy writes, what happens is the DHCP server gives an IP address to the clients, and then it updates its partner as to what it's done. So that's cool, it kind of works all right. But there's a bit of a problem. If the server fails after giving an IP address to the client, but before it's updated its partner, the partner's going to think the address is still available. And the partner's potentially going to allocate that address out to someone else. And then you're going to get 2 IP addresses on your network, and we all know how much of a pain that is to try and solve. So the IETF draft, and Microsoft do the same thing, has this timer. And it's called the max client lead time. So what does this timer do? It does 2 things. The first thing it does is it says, if my partner server doesn't know anything about this client that's just come to me, the maximum lease that I can give the client is the max client lead time. Okay, it's not the scope settings, it's the max client lead time. Okay. The second thing the max client lead time does is if you're in a failure situation and your server's transitioned to partner downstate, and we're going to go through that next, it's the amount of time the server's going to hold its partner's addresses essentially in escrow before it says they're free to be used. Now, the reason it does that is it doesn't want to do duplicate IP allocations. So it says, I'm going to hold my partner's addresses for the maximum lease that it should have given any clients, and then I'm going to know that those addresses are free and that I can reallocate them. So I think a bit of an example's in order to see how this all holds together. So imagine, if you will, we've got two DHCP servers, S1 and S2. They're configured in a 50-50 failover relationship. They're server 2012, obviously. We've got a configured lease time of 3 days for our scope, and we've got a max client lead time of 1 hour. And we've got a new client that's just come onto our network, C1. So C1 sends a DHCP discover. Now, the first thing that's going to happen is only one of our DHCP servers is going to respond. And this is different from 2008 R2. When you configure your failover relationship, as well as splitting the address pool up between the two servers, they also split up all potential clients between the two servers, and they split it based on the based on the ratio that you've chosen. So S1's going to respond, and S1's going to give C1 a lease of 1 hour. It's going to do that because S2 doesn't know anything about C1, doesn't know what S1's going to do. Immediately, S1 goes to S2 and says, this is what I've done. I gave C1 a lease of 1 hour. But S1 also tells S2 something else. It says, next time, I'm going to give C1 a lease of 3 days. So it wants to get its partner ahead of the game. Because if its partner's ahead of the game, then it can give the client the full lease. So let's see what happens. So 30 minutes goes by. Now the reason it's 30 minutes is because the clients always try and renew their IP address at the half-life. In this case, it was a 1 hour lease, so it's 30 minutes. So C1 sends a DHCP renew to S1, and S1 responds. And it gives it a lease of 3 days. And it can do that because it told its partner that's what it was going to do. There's no risk here that its partner's going to think the address isn't in use. C1 then updates its partner and says, S1 updates its partner, I've just given the client a lease of 3 days. But then it tells its partner what it's going to do next. So I'm going to give it a lease of 3 days plus 1.5 days, because I expect C1 to renew its lease after 1.5 days. And the next lease that I want to give it is a lease of 3 days. So pretty simple once you've got your head around it. But what happens in a failure situation? Because let's be honest, that's what we really want to know. That's what it's for. So S1 fails. It's disappeared from the network, gone. So the first thing that happens is S2 goes into communication interrupted state. Now, in communication interrupted state, it doesn't know if S1's down. It just knows that it can't communicate with S1. So it starts hedging its bets. And it says, well, look, I'm going to respond to all DHCP requests that I see on the network, but I'm only going to respond to them out of the pool of free addresses that I've currently got. Now, it's quite important if you're running in a hot standby scenario. You need to make sure you've got enough free addresses on your standby server to support new clients as they come in, and we'll look at that in the demo. So C1 gets to 1.5 days and says, I want to renew my IP address. And it sends that renew. Now that fails. S1's still down. Something's gone wrong with it. So C1 keeps on using the IP address that it had till it gets to 87% of the lease. And when it gets to 87% of the lease, it does what's called a DHCP rebind. And it sends a broadcast request out. S2 receives that request. Because it's in communication interrupted state, even though C1 isn't one of its managed clients, it responds. Now, again, this is where it gets a bit interesting. S2 has a lease for C1 in its database. It can't extend that lease any further, but it can give C1 the rest of that lease. So we've got 80% of the way through our 3 days. So we're going to get a lease back, which is probably about 1.8 days. Now, S2 will continue this process of renewing the lease until the max client lead time is bigger than the lease. Because remember, it can't renew the lease because S1's still down. Any new clients that come onto the network are only going to get a lease of the max client lead time of 1 hour. Now, remember I said S2 is only working on the pool of addresses that it had available when S1 failed. So there's another step here. You either have to manually go in and tell it that it's in a partner down state, or when you configure your failover relationship, you'd have to tick the box to say auto state failover. Now the reason that's not on by default is if you're running a monitoring tool such as SCOM, you may choose to have it automatically run the PowerShell command when it detects that the server's down. Because remember at the moment, when communication interrupted state, all S2 is saying is I can't talk to it. It may still be running quite happily. So in partner down state, S2 seizes all of the addresses that its partner had. So it fills up its cache. But as I said before, it can't use those addresses until the max client lead time timer is expired, because it says prior to going to partner down state, it may have been running fine. It may have given leases out. I need to wait until all those leases have expired before I'll start using those addresses. It really doesn't want to allocate duplicate addresses on the network. So let's have a look at a demo, because that was all, I understand, a bit detailed. Hopefully we can see in the demo how it sort of hangs together a bit more. How are we going for time? So I've got two DHCP servers here. I've got DC1, which is my domain controller, and I've got member server 1, which is my secondary DHCP server. And I've got one scope, which is configured for failover already, and a scope that we're going to set failover up on. So if we right-click and we go to properties on this scope, and we go to failover, so we can see here we've got a failover relationship in place. We've got a relationship name, which is really important. We've obviously got our partner server. The mode for this failover relationship is load balanced. Now I've monkeyed with the timers here. I wouldn't suggest anybody sets a max client lead time of 2 minutes. You're going to have lots of load. And I've got a state switchover interval of 5 minutes configured. Again, this is so we can do a bit of a demo in a minute and see sort of things happening. And we'll see that both servers are in a normal state. We can also go in up the top here and go properties. And we can see all of the failover relationships that are configured. So let's go and add a failover relationship. It's got another scope here. We're going to go configure failover. The first thing it's going to do is say, look, do you want to just do it for everything? And just to be on the safe side, we're going to choose that one scope that we've got. Now, it tries to be helpful. So the next thing it's going to say is, look, if there's an existing failover relationship, do you just want to use that for this new scope? So we're not going to do that. We're going to create a new one. So it's going to suggest a relationship name. I suggest that you change that to something which makes sense in your environment. For here, I'm just going to leave it as default. The max client lead time defaults to 1 hour. There's a reasonable amount of science behind that 1 hour if you do a bit of a search on the internet. So if you're going to change that, and I'll talk a little bit after this demo, you just need to understand what's going to occur when you change that. And changing it at one point is going to blow stuff out if you're in a failover, if you're in a failure mode. But we're going to change this from load balance to hot standby. So this is the important bit here. Addresses reserved for the standby server. So remember how when we just went through, we looked at when we're in a communication interrupted state, we don't get access, we only have access to the addresses that we'd reserved within our pool. So if I've got a hot standby server and I haven't reserved any addresses for it, when I'm in communication interrupted and a new client comes on, I'm not going to have any addresses to give them. So we only need a small number of addresses because existing clients are going to be in the database. It's going to renew those leases without any problem. But if you're a campus or a university or you've got a highly contested scope and lots of clients coming and going, you may need to increase this reservation depending on how your scope looks. And we've got this state switchover interval. And I'm going to turn that on for this one. So this is going to automatically transition from communication interrupted to partner down state. If we don't tick that, it's not going to do that automatically. We're going to have to go in via the UI or PowerShell and set that. And we need to give it a shared secret. So that's going to go ahead, it's going to connect to member server 1, and it's going to set up that failover relationship. And if we go here and do an F5, so now we see our scopes appeared on our secondary server. And if we right-click and look at the properties on that, and go to failover, we'll see that the role of this server is the standby server. Now, the next really important thing that I want to show you is this. If we go in and we make a change to the scope setting. So we're going to change this to 4 days. And we're going to go back to here, and we're going to refresh that. And we're going to go to Properties. The scope is still 1 day on our secondary server. Okay? The failover relationship only deals with address lease information. It doesn't automatically synchronize our scope settings. So what we need to do is if we're changing our scope settings, we need to go in, we need to right-click, and we need to go Replicate Scope. And that's going to go ahead and it's going to push the scope settings back out to our secondary server. Did I refresh that? Hopefully I did. It changed? Yeah. Okay. I asked the DHCP developers about this, and they said, look, they were going to have it automatic, but then they thought there were certain circumstances where organizations might want some slightly different settings on their standby scope, so they left it with a manual step. Now, there is a PowerShell command that you can run as well that will replicate those scope settings. But it's something to be aware of. You don't want to fail over to your standby server and find 6 months earlier you changed your default gateway for your scope, and suddenly all of your clients have now got the old default gateway and can't get anywhere. When we look at IPAM, you're going to see how you can see all of those scopes in one screen and potentially pick that up there as well. But let's do something a bit risky. Let's see what happens when things start to fail. So we're going to stop the DHCP server on my main server. And we're going to do a remote PowerShell session to member server 1. So that's the secondary DHCP server. And let's have a look at that failover relationship. So that failover relationship's gone into communication interrupted state. We can see my max client lead time is 2 minutes, and my state switchover interval is 5 minutes. And we can, in PowerShell, and I really like this command, we can have a look at the IP addresses that we've allocated, and we can see which server allocated that address. Now, that's something you can't see in the UI. So let's go and start up another server. And let's rerun that. Here we go. So that server's come up, it's done a DHCP request. This time, server 101, which is member 1, has given it an address. But also look at the lease expiry, 2 minutes from now. So we're in a communication interrupted state, we're only giving out leases of 2 minutes. And just for a laugh, we'll go in and we'll set that to partner down state. And so now when we go and have a look, we're now in a partner down state, and it seized all of those addresses. Now, even when it's in partner down state, it's still going to only give out leases of the max client lease time. Now, the reason for that is when S1 comes back up, or when your other server comes back up, you don't want all of your clients sitting on your hot standby server for the next 7 days, 4 days, whatever your scope's set to. It really wants all of those clients to go back and to be balanced across or go back to your primary server. So in a failure situation, you're only going to give out addresses of the max client lead time. let's exit out of that. And we'll just start the DHCP server back up, otherwise we get an error in the next demo. Right. Okay. So, to recap, you need to make a decision on your state switchover interval. You need to decide, are you going to have your failover relationship automatically transition to partner down state? Are you going to monitor it some other way and trigger it? Are you not going to worry? Are you just going to say, look, we don't have enough congestion within that address space. If it only uses half the pool, it only uses half the pool. You need to be really careful changing your max client lead time default. So if you do a max client lead time of 8 hours, that's going to be great. When you're in communication interrupted state, you're going to give out these really long addresses. You're going to have to wait 8 hours before you seize the addresses from your partner. So you've got to be careful about that. And I think the most important thing is replicate scope changes replicate changes to your scope. So if you go in and make a change to your scope, replicate those changes. And you might want to think about deciding a primary DHCP server and a secondary DHCP server, even if they're going to be a 50-50 split scope, so that staff know that's where they go and make changes, and they replicate that information across. And when you're doing your checks, check to make sure that you don't have a mismatch between those scope settings. Okay, all of the DHCP server commands are also available as PowerShell commandlets. If you just want to get the failover commands, then do a get command module DHCP server, but pipe it through select string and look for failover. That'll just give you the failover commands. And I talked about partner downstate. That's the PowerShell command to run to put a failover relationship into partner downstate. Now, you can only run that command if the relationship is in a communication interrupted state. If you try to run it when it's normal, you'll get a big error message. Okay? So, IP address management. So this is a brand new feature in Server 2012. And what is it? Well, at its heart, it's a tool for tracking the allocation of IP addresses. Essentially, it's a replacement for your Excel spreadsheet. How many people here have an Excel spreadsheet in their network tracking their IP addresses? Yeah. How many people have more than one copy of that sheet? Yeah. Look, it works well, don't get me wrong, but there are some issues, right? It's not multi-access. People take copies. People forget to update it because it's locked and they can't get to it. IPAM solves a lot of those things, but it also does quite a few other really quite interesting things as well. So, always said, it's new to Server 2012. Unlike DHCP failover, IPAM can track v4 and v6 addresses. Okay. As we'd expect, it uses the new Server Manager management console. So you get true multi-user access. And it's got a client-side management console which you can install on Windows 8 clients and above. Now this is quite interesting. As well as doing all of your IP address tracking, it also gathers IP-related information from your DHCP, your DNS, and your AD servers. And it does this in an agentless manner. And I'm going to take you through that after the demo. Because it gathers that data, it turns it into a bit of an auditing and reporting tool. And there's certain Sarbanes-Oxley requirements which IPAM fulfills. And one of the things you can do is you can actually run audit reports on your IP address leases across all of the DHCP servers in your forest. So if you want to track a client and see where it's gone between your different sites, As long as they're all Microsoft DHCP servers, you can report on that from the one IPAM console, which I think is pretty cool. But I think the main thing for a lot of organizations is this. I think you can get rid of your Excel spreadsheet. Right. I think we just should go straight into a demo, because this is pretty new, and have a look at it, and then I'll take you through a bit of the security, how agentless monitoring works, and how to do the installation. We're looking like we're going pretty well for time, but if Nathan bursts into the back of the room with a laptop and starts waving, we'll cut through some of this. So, I better switch across so you can see, eh? IPAM. You get a bit of a heads-up display when you first in the overview, but let's go straight to our server inventory. So that's a really good start. We restarted our DHCP server in time, so we don't have a big error message. So what we've got here is these are the servers that this IPAM server is monitoring. So it's monitoring my domain controller, and it's monitoring member server 1. And it knows that my domain controller is a domain controller, a DNS server, and a DHCP server. Now, manageability status, managed, IPAM access status unblocked. Okay, when you first discover your infrastructure servers, they come in as management status unknown, and then you set them to managed if you want to manage them. Now, immediately when you do that, the IPAM status is going to come up as blocked. Don't panic. IPAM uses group policy to configure the servers that you want to manage so that your IPAM server can access them and gather the audit data. So it has to wait for group policy to apply. So when you first set it, it's going to go blocked, it's going to look red, you're going to go, oh my goodness, I've done something wrong. You either go to the server and do a GP update, or just wait for your group policy to apply, and they'll transition through to an unblocked state. So IP address space. So the IPAM server has this concept of IP address ranges. And essentially, these are the subnets that you've got on your network. They're the subnets that you've got in your DHCP scopes, but they don't have to be in your DHCP scopes. They're any subnet that you're allocating on your network. And these subnets, they roll up into address blocks. And they don't have to be internal addresses either. It knows about external addresses. It knows about regional internet authorities. And the purpose for this roll-up is essentially so you can see within this block, what's my allocation looking like? How many IP addresses have I allocated? Am I running out of space within that block? So if we go to our IP address ranges, we can see here that it's picked up the scopes that I have on my DHCP server, and it polls every hour or so, so it's not absolutely real time. And I've got two other scopes here that I've created for testing. And down the bottom left-hand side, we can flick across to our IPv6 scopes, or ranges. So how do we allocate an IP address? It's actually really easy. We're going to do this in v6 because, well, there's a whole heap of typing you have to do with v6. It's much longer. And I think that IPAM really shows off how easy it is when you see how little you have to type. So we're going to right-click, and we're going to go find and allocate available IP address. So the IPAM server is going to go, it's going to try and ping the address. All right, yeah, it's a good try, but likely is it's not going to be able to do that. But it's also going to have a look in the DNS and say, is there a reverse entry for this address already? If there is, I'm going to put a warning up and say, ooh, it might not be free. It's also going to look in its own database and say, have I allocated it before? So let's go to our basic configuration. So we're going to choose :3. So now we need to start filling out a bit of information. So in this case, I'm going to set an assignment date. We're going to assign it today, and we're going to set an expiry date. Well, actually, we want this address back in a month's time, right? It's temporary. And we're going to call this switch 3. And we're going to say, look, we're going to allocate it to NSO, Network Security Operations. We could do a DHCP reservation, but in this demo, we're going to do a DNS records. So again, we might have a different DNS name than what we internally call this device. In this demo, it's just going to be switch 3. Then we need to choose the zone that we want to register this entry in. So I'm going to choose my Active Directory integrated zone. And we need to choose the server that we want to do that entry on. Now, the reason for that, IPAM can run across a forest, across multiple domains in your forest, and you may want to target a server very close to where the address is going to be in use, so you don't have to wait for replication to occur. And we're going to choose a reverse zone. IPAM's smart enough to know that there's only one reverse zone available in my DNS, which matches this IP address. And again, we're going to choose that server. Now, we could go in, and it's fully extensible, the database that sits behind this. It's a Microsoft internal database, which is only available to Microsoft applications. But we can extend that out, and we can add any additional fields we want into IPAM. I'm going to keep it simple and click OK. So if we go up to our IP address inventory, and we go down to our IPv6, we now have an IP allocation for switch 3. Has an address, and it's not expired. I'm going to slide across. So we added in some DNS host information and some reverse information. So we're just going to right-click, then we're going to go Create DNS Host Record. And we're going to do the same for our PTR record. So this has gone out, and this is connected to our DNS server, and it's put those entries in. So let's go and have a look on our DNS server. So the first thing I'm going to do is refresh. So that pops up. And everything going well. There we go. We've now got a quad A record for switch 3. And we've saved ourselves 128 characters. Might not seem much, but when you get the 127th one wrong, it takes a while to figure out, okay? So we're reducing the amount of data entry we've got to do. We're not putting it into a spreadsheet and then copying it and then going to DNS. We're doing it all from the same place. And just to risk it even more, we'll go and do a refresh on our reverse entry and make sure that that's come through as well. And it has. And we can retract those as well. So we can right-click and we can choose Delete Entry. So we don't have to touch our DNS. The IPAM server is going to do that for us. So monitoring. So this is the other side of it. And I think this is actually just as useful as the IP allocations. So it knows our DHCP and our DNS servers. Okay, this is more focused on those, not AD. We can see all of our DHCP scopes across all of our DHCP servers. So we don't have to go into each of our DHCP servers and look at the scopes. We can look here, and we can get a bit of a heads-up view about those scopes. We can see whether they're underutilized or overutilized, whether the server's down or not. And we can do some interesting things like highlighting multiple scopes and editing them. And that's going to make that change across all of those scopes on our different DHCP servers. So if you've got NTP setting or something like that, you can change it at this one point across multiple scopes, across multiple servers. And now from our DNS side of things, we can see all of our DNS zones, which are hosted on our DNS servers. And we can see the status of those, and we can see which servers are authoritative for those. Now, under our event catalog, this is where we can see our IPAM audit configuration information. We can have a look, we can see our DHCP server audit information. And I think the most important thing is to be able to go and look at our IP address tracking. So this is a search I did earlier. We can see here for this client, I can look back and I can see every single time that it's renewed its address in the last 30 days. Now, this holds, a single IPAM server is designed to hold 3 years' worth of IP tracking information for 100,000 clients. I don't know how much disk space it requires for that, but it doesn't automatically purge that data. So if you've got less and you want 7 years' worth, you can get that. It's compatible with 2008 and above. So you don't have to have R2, and it's DNS and DHCP and AD. Right. Let's get back into the presentation. So, security roles. Oh, no, you guys can't see that yet. There are 5. They go from read-only all the way through to full admin access. Thing to note here, to track IP addresses, you need to be in the IP audit admins group. Okay, we don't really want a normal user being able to go and track people around our network. People get a bit uncomfortable about that. Agentless monitoring. So I talked about this, and I said that it used group policy. So what it does is there's 3 group policies that get created in every domain in your forest that you want to manage servers in. And they relate to DNS, DHCP, and your domain controller. And when you set your server status to managed, IPAM takes that machine account and adds it to the security filter for the group policy in that domain. Now that group policy sets the settings that are required for the IPAM server to manage that role. There's also a PowerShell script within that group policy, and that PowerShell script has the security ID of the IPAM server in it. So it's not opening up for everybody, it's locking it down so that only that IPAM server can manage that role. Doesn't affect your other manageability, but I don't want you to think that suddenly you're opening it up and anybody can do this. If you've got firewalls around your network, let's be honest, we all should, you are going to have to open up some protocols for this to occur. So, how do we do this installation? It's pretty easy, really. It's a feature within Windows. So we use the UI, or we run PowerShell. Install Windows feature IPAM. That's going to go ahead and do everything. Installs the embedded database and sets it all up. The next thing we need to do is we have to provision the IPAM server. There's essentially one question that the provisioning wizard asks you. It says, do you want IPAM to automatically configure the security on the servers that you want to manage, or do you want to do it yourself? I recommend you say, do it for me. I had a look at the PowerShell scripts and the group policies. It's really quite complicated. And if you miss any step, your IPAM servers, it's going to get pretty confused and things are going to be sort of a bit strange. But if you are in a really secure environment, or you've looked at the scripts and you go, yeah, I can do this, you can do it yourself. Once you've run that wizard, there's a PowerShell command that you need to run. And I think the wizard could do a better job of telling you that you need to do that. Okay? So for every domain in your forest that you want to manage a DHCP, a DNS, or an AD server on, you need to run this invoke IPAM GPO provisioning commandlet. And you need to do that from your IPAM server. So you need to do a remote PowerShell session to your IPAM server and run it from there. And you need to give it the domain, and you need to give it the prefix that you've configured in your wizard for those group policies. Now, all it's doing is it's copying those group policies out to each domain and setting the security so that your IPAM server can manage the security filters on those. Then you need to do a discover. Now, this isn't discovering your IP addresses. This is discovering your DHCP, your DNS, and your domain controllers, okay, the servers that you want to manage. Once the discovery is complete, they're going to turn up in your UI, and they're going to turn up as management status unknown, and you're going to go and set them to managed. And like I talked about, they're going to go red, and it's going to look really ugly, and you're going to go, what did I do wrong? If you want to force that, you need to go to each server and do a GP update force. The next thing you're going to want to do is, I think you're going to want to import the addresses from your Excel spreadsheets. IPAM has a full import ability. I found the easiest thing to do was to do an export first, get the syntax right, pad it out with all my other addresses, and import that. Okay? It doesn't import the leases from your DHCP servers. It doesn't go out and discover all the IP addresses in use. The discovery phase is all about those servers that you want to manage. So, capacity. Talked a little bit about this before. So a single IPAM server is rated to be able to manage 150 DHCP servers and 500 DNS servers. So has anybody got more than that in New Zealand? Yeah, so I think a single IPAM server is probably going to work quite well for most people. Now, Microsoft have tested it with 6,000 DHCP scopes and 150 DNS zones. And I said before that it's rated for 3 years' worth of IP audit data. Okay. So really, just to sum up, we've had a look at network interface teaming. We've seen that it's really pretty easy. Very simple to configure, but there's a bit that you need to understand about how the teaming modes work. We've had a look at DHCP failover and how Microsoft have really simplified that down in Server 2012. And again, we've looked at IPAM and we've gone, wow, that's pretty simple too. Microsoft are really trying to reduce the amount of data entry we've got to do here. These are just some of the changes that Microsoft have made to simplify your infrastructure. Right. I seriously recommend going along to Stu's session this afternoon, learn a bit more about highly available failover clusters. No, sorry, that was the one on Friday. Learn more about Hyper-V networking. There is a 2012 exam, the 7411. Now, if you want to contact me, feel free to email me. Here's my email address. Or I do blog sometimes at blog.mobiles.co.nz, and I'll try to put some additional information up on the blog. Now, the laptop giveaway. Is Nathan in the room? No. Has anybody else worked with Nathan before? No. It's not uncommon for Nathan not to be in the room when you need him. So how are we going to do this? Tony Murray asked a question in his session, and I'm going to ask a question in my session. I think the easiest way to do this is going to say the first person to put their hand up, but I'm going to need a couple of spotters. Can I get you guys to stand either side and just keep an eye out, because I don't want to look over here and find someone over there put their hand up.